there are some quadratic equations that don't really look like quadratic equations. And those are the type of problems we're going to look at right now. For example, if you have x to the 4th and you take away 10x squared, you add 9 and you get 0. Remember, to be in quadratic form, you have to be something squared plus a number times something squared plus a number times a something plus a constant equals 0. At least you have to be able to be written in that form. And what's in these two brackets, they both have to be the same. They don't have to just both be x or both be y's or both be z's. They can be other things. For example, x squared. Squared is x to the 4th minus 10 times x squared plus 9. The variable, like in this equation here, is a quadratic equation in the variable x. In this equation, it's a quadratic equation in the variable x squared. If it'll make you happier, say that you prefer to let u equal x squared. So then it's u squared minus 10u plus 9, and I should have said equals 0. Now this is more standard for us. I want, since it's understood to be 1u squared, I want two numbers that multiply out to 9, they add up to negative 10. And those two numbers are negative 9 and negative 1. Well, if this times that is 0, either this is 0, which happens when u is 9, or this is 0 when u is 1. Now, if somebody gives you the top equation and they say, please solve it, and you solve it and you come up very confident looking, and you say u equals 9 and u equals 1. And surely the person is going to look at you really strangely. It's like, my goodness, I give this person a problem involving x's, and they tell me what u equals. Now, you might be right, you might be wrong, but this person will never know, because you never told them u equals x squared. I mean, maybe you let u equal x plus 3 squared, or x squared plus 1. But nonetheless, you really shouldn't even tell them what u equals. U is really x squared. So it's either x squared equals 9 or x squared equals 1. What squared gives you 9? Plus or minus the square root of 9, which is 3. X squared is 1. So x equals plus or minus the square root of 1, which is 1. So we get 4 answers. And if the highest power is 4, and it is, the other powers of x are less than 4. The highest power is 4. You might get 4 answers, or 3 answers, or 2 answers, or 1 answer, or no answers. Here, we got 4 answers. X can be plus 3, x can be negative 3, x can be plus 1, or x can be negative 1. You get 4 answers. And we solved it just like a quadratic equation. We wrote it as a quadratic equation. Now, if you're told that r minus the square root of r, or actually, plus the square root of r minus 2 is 0. You may say, well, that surely isn't a quadratic equation. Well, it is. remember that r is the same as the square root of r squared. This is the square root of r squared plus the square root of r minus 2 equals 0. I mean, if the square root of r would say x, it would look fine. X squared plus x minus 2 equals 0. You say, yep, that's the quadratic. So what you can do is you can say let x or u be the square root of r. So x squared would be, you square the left side, you get x squared. You square that, you get r. So x squared is r. So this here is x squared plus this here is x minus 2 equals 0. That's a standard quadratic equation for us. You can solve this by completing the square. I'll try to factor it. X and x. I want two numbers, I multiply out the 2 and add up to that understood 1. Those two numbers are plus 2 and negative 1. And equals 0 still. This times that is 0. So either this is 0, that happens when x is negative 2, or that's 0, which happens when x is 1. But there was no x in this problem. Remember, x was the square root of r. The square root of r is negative 2. The square root of r is 1. Well, this has no solution. The square root of no number is ever negative. Whether it's negative 2 or negative 52. There's no answer. The square root of some number is 1. That means that number is 1. So here we had one answer. Now, we can have ones that are a little bit more complicated, or just look a little bit more complicated. Now, we know how to solve this one. X squared plus 5x plus 6 is 0. Want two numbers that multiply out to the constant, but add up to the number in front of x. Remember, you only do that if it equals 0. The two numbers are 3 and 2. 3 and 2 are 2 and 3. They add up to 5 and they multiply out to 6. So if this times that is 0, either this is 0, which happens when x is negative 2, or that's 0, which happens when x is negative 3. Now, what if the problem was a little bit more complicated? What if it were y plus 4 squared plus 5 times y plus 4 plus 6 equals 0. Now, notice that those are the same. Now, if I said let x equal y plus 4, well then this is x squared plus 5, and this we're calling x, plus 6 equals 0. Oh my. This is exactly that equation. And that one I had a factor. Not only do I know how to factor, I already did. So instead of x, I write y plus 4. Y plus 4 can be negative 2, or y plus 4 can be negative 3. You take away 4 from both sides, you get y can be negative 6. You take away 4 from both sides, you can get y can be negative 7. There's your answer. Okay. If somebody gives you this, if somebody gives you this equation right here, you should basically rewrite it where x is x plus 4, y plus 4, and then you continue here. let me actually write that up for you. Y plus 4 squared plus 5 times y plus 4 plus 6 is equal to 0. You should write let x equal y plus 4. So it was y, it's x squared plus 5 times x plus 6 equals 0. We factor this, x plus 2, x plus 3 equals 0. So x is equal to negative 2, or x is equal to negative 3. But x is really y plus 4. So y plus 4 is equal to negative 2, or y plus 4 is negative 3. Pass the 4 over. We get y is negative 6. Bring the 4 to the other side. Negative 7. Y is equal to negative 6, or y is equal to negative 7. Sometimes it may not look like a quadratic, but we can write it as one. Now, we'll do one more, and there are actually two different ways of doing this, so maybe we'll do it both ways. Suppose you have a problem like this. R to the negative 2 plus 6 r to the negative 1 plus 9 equals 0. Well, in some ways, this almost looks like a quadratic. I mean, if these negative signs were not there, it'd be a quadratic. R squared plus 6r plus 9. Well, remember that, first remember that r is the same as r over 1. The negative exponent is just the command to flip over the base, to flip over the r over 1. R to the negative 1 is r over 1 to the negative 1. And if we want to get rid of the negative sign, well then, not a problem. We just have to flip over the base. So, this is 1 over r squared. I kind of said that. 1 over r squared. Plus 6 times r to the negative 1, 1 over r. Plus 9 equals 0. Now, like all of the problems, if you want to deal with y plus 4, or x squared, or 1 over r, you can leave it that way. So, I'm just going to rewrite it. I'm just going to say, you know what? I don't like 1 over r. I like x better. It's my taste. So, x squared plus 6x plus 9 is 0. And two numbers that multiply up to 9 and add up to 6, well, 3 and 3 do that. 3 and 3 do that. I mean, this is just x plus 3 squared. And when is it going to be 0? Well, what two numbers multiply? Two numbers. I'm going to multiply 2. Same two numbers. I'm going to get 0. What those numbers have to be 0? X plus 3 must be 0. Which means that x should be negative 3. But x is 1 over r. It should be negative 3, which is the same as negative 3 over 1. If two quantities are equal, 2 over 7 equals 2 over 7. I don't think anyone would argue that. Well, if I take their reciprocals, they're still equal. If I take the reciprocal of this, I get r. You take the reciprocal of this, you get 1 over negative 3, which is the same as negative 1 over 3. And there is your only answer. R can equal to negative 1/3. How about we consider this type of problem? Let's thought of another good one that you should see. You have y to the 2/5 plus y to the 1/5 square and a 1. It's just that fifth, the 5 in the bottom. Well, just remember, this is the same as y to the fifth squared. When you multiply those powers and the poster, you get 2/5. Y to the 1/5, well, that's y to the fifth. That's the first power. If I let x equal y to the fifth, well, if you square y to the fifth, then you get y to the 2/5. If you square this, you get y to the 2/5. Well, if you square the right side, you have to square the left side. So y to the 2/5 is x squared plus y to the 5th is x plus 16 to 0. There's an understood one here. We want two numbers that multiply out to the constant, so they add up to the number in front of x. Okay, so this one I don't see how to factor. I don't know why that 1 didn't come out, sorry. So we try to complete the square. X squared plus x is equal to negative 16. And we decide what to add. Remember, there's a 1 here. You divide it by 2, and you square it. You get a quarter. So you add a quarter to both sides. Now, how about at the very beginning, make it negative 16? Make it negative 16. That way when I bring the 16 to the other side, it becomes positive 16. So add a quarter to the left, I add a quarter to the right. Now remember, 16 was the 4 in the bottom, you multiply, you get 64. Okay. So the left side is a perfect square. It is x plus this number, plus a half, squared, and this is equal to 64 over 4, that's 16, plus 1 over 4, 65 over 4. So then x plus 1 half is equal to plus or minus the square root of 65 over the square root of 4. So I take away a half from both sides. And I get x is equal to negative a half plus the square root of 65 over 2 or minus it. It's just shorthand notation for two different numbers. X is really y to the 1/5, which is either negative a half plus the square root of 65 over 2, or on the left, it's negative a half minus the square root of 65 over 2. In fact, they have common denominators. 2. Negative 1 plus the square root of 65 over 2. That's what y to the 5th is. Well, I don't want to know what y to the fifth. I want to know what y is. So you raise it to the fifth power. Y to the fifth power, because when I multiply those powers, I get 1, and y to the 1 is 1. So y is equal to negative 1 minus the square root of 65 over 2 to the fifth power. Now, I have no idea what negative 1 minus the square root of 65 times itself 5 times is. But I sure know what 2 times itself 5 times is. It's 32. So that's one answer. Raise to the fifth power, get 1. Y to the 1. Raise this to the fifth power, raise the numerator to the fifth power. You just get that. Raise the denominator to the fifth power, you get 32. 2 times 2, 5 times 32. And that finishes this problem, this section.